let's see what we got. So we got, everybody responded, which is great. And let's see, so we did get one person who thought that attendance is required, but points are for being on Zoom, but no participation is required, which is not correct. Participation is required. You have to participate on Jamboards with your group, and also do your handouts and upload your handouts as proof of participation. This next one here, one person has said exams are on Zoom and worth 60% of your grade, which is not true. Your exams are only worth 40% of your grade, and they are on Proctorio, which records video of you that only I can see. And then textbook requirements. One person said if you purchase My Math Lab online, you have to purchase it again. You do not. If you purchased online access for algebra at Las Positas College, so 65, 110, or 55, you do not have to buy it again. You can just, you can just still use it. And if it gives you trouble, like it says you have to get a different version, or it says it isn't valid, send me your information, your username, your name, your email that you use for the account, and I will, actually I'll send you a form, and you fill out the form, and send it up. We've got that streamlined now, and they'll upgrade your account to the correct version. So even if you purchased it 5 years ago, it's still fine. It's no big deal. And then this one, we had a couple people who thought, one person thought you had to sign up. Oh yeah. So which is not true. This is true. You have to sign up for My Math Lab by September 7th, or you may get dropped from the class. This is also true. After every lecture, you have to upload pictures of handouts saved as PDFs in order to get the other half of your attendance and participation grade. You have to do both of those. This is the one that's not true, right? If you never do homework, you won't even pass this class, because I think homework's worth 30% of your grade. So you have to get 100% on everything else in order to pass. Okay, so let me move this out of here and talk about what we have next. So next we're going to talk about accuracy, precision, and estimation. So that is pages in your handbook. Go there. Then get your papers out. We are on page 17. Looks like this. Only probably black and white. So everybody turn there, get there. And let's get a reader for this one. How about some of this is not visible, so it's better. Julian, go ahead and read for us. Hello, go ahead and read.
Can we go to me?
Yeah.
Which one?
From the beginning, from the top.
Introduction. Have you ever heard someone ask for a
Oh, you gotta turn towards your microphone. Okay, so we'll speak up as loud as you can then.
Right. Have you ever heard someone ask
Whoa, what you doing? So what you were doing earlier was better than what you're doing now, so.
I just lifted the bottom and make it do that.
Yeah, no, don't do that, yes.
Should I expect from the beginning?
Yeah, I think it's probably near wherever you are now is perfect. So go ahead.
Alright.
Yeah, it's often near the camera.
Alright. Have you ever heard someone ask for a ballpark figure? What do they mean? Phrase comes from the American of baseball, and it's likely an expression of the summer earlier in the ballpark meaning using a reasonable range and artificial meaning beyond the
So,
Deal with numbers. Ballpark figures or estimates can be a useful tool in performing computations. You can use this in rounding off or using estimates for performing calculations. Yes, not just for
keep going.
While you may not be planning to major in rocket science, understanding the importance of precision and accuracy can be just as important for managing your finance, the figuring out the specific area of the exterior of your home, particularly in engineering experiences.
Perfect. Terrific. Precision versus accuracy. Michael G. Go ahead and read for us. Right here.
In everyday speech, people tend to see the use for accurate, but and interchangeable. But in mathematics, they're different. The ruler measures the line, draws the line, give your answer.
Okay, so say we all measured this. If we all measured this, we would all get, even if measured it on paper, so they all look the same, we'd all get slightly different answers because we'd all would have, some people would round to different, would round to the nearest tenth of a centimeter, some people might try to round to the nearest hundredth of a centimeter, and also even within that, people might read it slightly differently. So they're all going to be slightly different. Some will be the same, and some people would do them slightly different. Go ahead and keep going from here, Michael.
Your ability to find actual step length of the line is determined by how accurate of the device you were using to measure, and your own ability to teach that device. Lasers are often used to measure distance because they are far more accurate than humans. Humans may measure devices such as rulers and then
Mathematicians.
Mathematicians and scientists talk about accuracy. They are referring to how close to actual something is measured. Because absolute accuracy can be difficult to attain. We sometimes estimate how far something measurement can go and
Perfect, thank you. Right, so for example, a measurement of 5.75 centimeters, see this little plus or minus 0.02 centimeters? That means that an acceptable measurement may range from 5.75 minus 0.02 to 5.75 plus 0.02. So it'll range from 5.73 to 5.77. That 0.02 is referred to as the tolerance, or error. If you go into statistics next semester, you'll call that error. To put it another way, if our measurement comes in at 5.74 centimeters, then we're in the ballpark in terms of acceptable accuracy. It's common sense to see tolerance used when seeing the results of a public opinion polls. You'll see that a lot. That's called the margin of error. So a lot of times you'll see polls like we're coming up on the presidential election, and they're like, I don't know, Biden is, has, 46% of the population with a margin of error of 2%. That means plus or minus 2% is what they're estimating that error to be. So it's in that range of plus or minus that amount. How about Josh S. Josh S. Go ahead and read. Or right here. So let's assume that we did measure these, and let's assume that people were pretty close, but not necessarily perfectly accurate. So go ahead and keep reading.
So if one of your measures side A has 2.5 centimeters and someone else measures 2.6 centimeters, then we'll say you're pretty close to one another. If you were to say we're pretty close to one another, then the measure's more precise. One meaning of the word precision has to do with how consistent and series of values are with each other. A second meaningful type of precision has to do with the number of significant digits you have in your measurement. A measurement of 2.5 centimeters has two significant digits. A measurement of 2.503 centimeters has four significant digits. The more significant digits you have in your measurement, the more precise it is. The significant digits in a number are those that relate to its precision.
Perfect. So that's good. So here's the thing. Significant digits are going to come up. You're going to get them in. Who's taking statistics eventually? And you guys? So you're going to take statistics. Significant digits comes up in there a lot. This is how it works. This one here, 2.5. There's two significant digits, the 2 and the 5. That's it. Over here, I start with the 2. I kind of end with this 3 over here. I've got 4 significant digits over here, the 2.503. Do you guys see that one? That's got 4. There are a couple of rules. All non-zero digits are always going to be significant, right? If it's not a 0, it's always going to be significant. So like 17 has, this number here, number 17, has 2 significant digits. Number 16.251, that's 5 significant digits. If your zeros are in between, like this one over here, 2.503 we had up here, those also count. So basically you have, that's okay, so yeah, so you can kind of see here these examples. 107 has 3, 1.005 that has 4 significant digits. However, leading zeros, in other words, zeros in front are not, they don't count. So so here, you guys see this 0.0012? The ones in front don't count. This one here only has, go to the first non-zero. Once you hit that, start counting there. So I'll count the 1, that's the first one. 2, that's the second one. So this one has 2 significant digits. Does everyone understand that? Does that make sense? And then, but the ones in the back are significant because that means that you're accurate to that decimal place. So the ones behind are. So example, here, 5.7300 has 5 significant digits because we're saying that this is accurate to the nearest 100th, 1000th, 10,000th. We know that this is not 5.7301. We know it's 5.7300. We know it's that close. It's not rounded to the nearest 100th. It's rounded to the nearest 10,000th. So we know that that's accurate to that level. So we count the ones in the end because those matter. Right here, 4.000, that's not the same thing as 4. 4, let me explain what I'm talking about here. Oh, I don't have a touch screen. Darn it, I hate I don't have a touch screen here. All right, so 4, this could be 4.2, 3.8. Do you guys see what I'm saying? If we just have 4, because it's rounded to the nearest whole number. We don't know. But 4.000, we know that's not 4.2 or 3.8. That's good to the nearest thousandth. It's that accurate. That's a huge difference, and it matters. Okay, so that would be 4 significant digits. All right, so what we're going to have you guys do is take a look at these. These are important, especially in healthcare. It's really important. Automotive technology, it's important. Anything you do that's diagnostic. Construction, it's also important there as well, right? Precision and accuracy matters, and knowing how precise you are matters. So I'm going to have you guys go ahead and hop back into your groups, go to your Jamboards, and go to the, kind of towards the back, so page, what is this? Page, oh, there it is. Page 13 in your Jamboards is going to be this. So go ahead and hop over to page 13. Again, here are your Jamboards. I'll go ahead and send this in the link again in case you didn't have it because you're in a new group. Bye, Ronlyn. Take care. And go ahead and hop into your groups and go to your group. So take note of what group you're in. You're in a different group than you were in that very first part. So watch your breakout room when it comes up so you know what room you're in, and then go to this link in the Jamboards and go to your correct Jamboard, page 13. So we've got like 4 pages, the rest of the handout. So there's like 4 or 5 to work on, 4 or 5 Jamboards. Haley, if you look, did you see? Did you find it? Oh, Liliana, Liliana, you are in group 2. Oh, where's group 2? Yep, group 2. And Haley, Haley, if you can, there should be at the very bottom near your leave spot, should be a spot to join. Billy, you're not joining either. What's going on? So Haley, towards the bottom. Haley, if you want, log out of Zoom and back in, and then it should pop up if you can't find it. But usually on the bottom, near the breakout, near the leave button, there should be a spot that says, you know, you've been assigned a room, something. Go to that room. What was that? Okay, great. Okay, let's get these other ones up. Oh, I'm gonna stop.